Two restrictions. So let me also wait for a couple of minutes for everyone else to get in. So rational equation, we have to state two restrictions for the variable. Can anyone tell us which restrictions? Which restrictions we have to write? That x does not equal
0.
Excellent. And from here, x does not equal
-3.
Excellent.
Negative.
Very good. Awesome. Great job. Thank you very much. I recommended this method, but again, I don't force you to use any of my methods unless they are clear and easier. The least common denominator, that's our next step. Remember, if I forget the equal symbol in 0, I move this term to the other side, it became negative, and if I forget the equal symbol in 0, then I don't solve, I just factor. So can anyone give us the least common denominator of these three fractions?
X plus 3 times x times 4.
Excellent job. Great job. All different factors have to be in the least common denominator. Awesome. This denominator has x, but it doesn't have the other two. So it means that I have to multiply the numerator by the other two. 4x plus 12. The next denominator has x plus 3, but it doesn't have the other two, so I have to multiply the numerator by 4x. The last denominator has 4, but it doesn't have these two, so x squared plus 3x. Luckily, we only have 1, 1, 1, so there is nothing I can distribute, so it's 1 times 4x plus 12, so it's 4x plus 12 plus 1 times 4x minus 1 times x squared minus 1 times 3x. At this point, combine like terms, present everything in the correct order. This is the first one. 4x plus 4x is 8x. 8x minus 3x is positive 5x, and then plus 12 over 4x, x plus 3 equals 0. Here I have two options. I either say a fraction is 0 only if the top is 0. Or I put this over 1 and I cross multiply and I get the same thing. Now this is quadratic, what we've been discussing all along. I refuse to solve a quadratic equation. That's another simplification situation. I need to simplify or factor. In this case, I simplify. I refuse to solve a quadratic equation with a negative leading coefficient, but that's me. So I will multiply both sides by -1. This times -1 is x squared. This times -1 is -5x, -1 times 12 is -12, 0, -1 times 0 is 0. And now I have 4 methods. Will I complete the square? Of course not. Will I take square roots? No, it's not set up. So I'm left with factoring or quadratic formula. If it takes a blink, I'll factor. If it takes a minute, I will not. So, can I find two numbers whose product is -12 and whose sum is -5? No, I cannot. So this is not factorable, so my only chance is to use the quadratic formula. It's set up correctly, 0 on one side, everything in descending order. -b, plus or minus, b squared, 25 minus 4 times 1 times c. I would have to put parentheses because this is a negative number, but I have a minus in front and this is negative. I will make it easier on myself. Divided by 2a. I will perform the operations. If you want, you can use a calculator, there is no need. So plus 4 times 12, which is 48, but anyway, and I get 73. So the final answer, x, 5 plus or minus the square root of 73 divided by 2. There is no need to separate them in writing. My lab math will ask you to. My only thought is, no, they are not. None of them is 0 or negative 3, so these are the solutions. I also wanted to look at a problem, a word problem, but let me know if you have any questions here.
That's the answer right there.
There is nothing else we can do. There is nothing else we can do. Yeah. That is all. So now, I'm sorry?
What happens when you try to keep going? Like why can't you keep going from that?
No, you cannot take the square root from 73. If the problem is asking you for an approximation, you can continue putting it in the calculator. But normally we don't want approximations. Unless I have to tell you I have in my pocket or in my wallet 5 plus the square root of 73 over 2, that makes no sense. And then I have to give you the amount. So 5 plus the square root of 73, I put parentheses everywhere I need to, and divide by 2. Now the other one, I just copy everything and override. And I get this. So if the problem is asking us for approximations, I would write negative 1.77, comma 6.77.
Okay. But like, say like, when we're writing it in the quiz that we were doing, you would just like write it like you did in the calculator, kind of?
Yes, so you have to write 5 plus the square root of 73 over 2, comma 5 minus the square root of 73 over 2. I recommend putting the smaller solution first. 5 minus the square root of 73 over 2, comma 5 plus the square root of 73 over 2. Like this.
Okay.
Thank you. So I would like us to look at a word problem to see where is this applicable. Why do we even bother with quadratic equations? Why do we?
Hypothetically, if you get a 0 in the square root position in this formula.
Very good. Excellent question. Excellent question. I didn't get the chance to talk about that, but it's a perfect moment. Thank you. Let's talk about the discriminant. The discriminant is normally denoted by delta. That's not important. B squared minus 4AC. When you ever compute this, there are 3 possibilities. Because this is a real number. It can be a number that is positive, it can be a number that is 0, and it can be a number that is less than 0. These are the only possibilities. And what happens in all these situations? In the first situation, when I have x equals negative b plus or minus the square root from a positive number divided by 2a, first situation, situation 1, situation 2, situation 3. 1, 2, and 3. In this situation, there are 2 x values that are distinct. Like, distinct meaning not the same. 2x values like 5 and negative 3, 2 and negative 9, 10 and positive 7. 2x values that are distinct solutions. In the second case, oops, when I have negative b plus or minus the square root of 0 divided by 2a, I have one solution. Actually, two identical solutions. Like you found a few minutes ago, and you said, what do I do? There is only one solution. True, one solution, because the discriminant is 0, but they're actually two identical solutions because we are still talking about a quadratic equation. In the third situation, what happens? Can anyone tell us what happens in the third situation when the discriminant is a negative number?
You have to take out I.
Correct. No real solutions. Two imaginary solutions. Great job. Thank you for asking. It will not give us time to finish the word problem because it's 12:15 and I'm not allowed to. It's a token of respect. I have to stop. But we are going to look at this problem and other problems